So in this tutorial, I will basically try to make a game where I can move my player with point and click, right? Like League of Legends or Dota. So let's just get started. So we have camera here, we have scripts, we have box and plane. So first of all, we will need a physics engine. Let's just set it up. Just go settings and physics and click import. And then we are going to create a folder called scripts. And then we are going to create a script called camera. Camera will basically calculate the positions, right? So let's just attach that camera script to it. Let me explain what I'm going to do right now with this game. So we have the plane, right? We have the camera here. So let me just like this. And so we will basically send a raycast from camera to the ground and calculate this position. So our player can just look at to this position and walk to there once we click, right? In order to do that, we will need a raycast function. So let's just set this up, right? So first of all, we will listen mouse of the application, and we will listen that so once users click down click down to the screen, it will basically trigger that function called mouse down on the camera, right? So and we are going to get an event, right? Because mouse has this event. Let's just see what kind of information that event gives us, right? So once I click anywhere on screen, it basically gives us X and Y position of my mouse, right, on the canvas. So I'm gonna use that information, and I'm going to create a function called raycast, right? Set raycast. So let me just create that function. So this function will have an event, and this event has mouse and X and mouse Y information. So I need to find this mouse position in 3D world, right? Because this is a 2D position. This is like this 2D sequence position. I need to find somehow where is this on the 3D world scene. Thank God we have this functionality on camera, and it's called world to screen. Sorry, screen to world, right? So screen to world function is basically giving us the 3D world position information of mouse click or anything, any position, right? You can basically, for example, you can basically find the center, like you can get the center of the camera, and you can send the raycast to this position and do a shooter game with that, right? So anyways, we're gonna use that function, and it's under camera entity. So this script on the camera, right? Camera, and we have the camera component here, and this functionality is under camera component, which basically this entity camera and screen to world function. So this function has I guess 3 parameters, yes. And now what we're gonna do is basically get event x, which is basically the mouse x position that we get from mouse down, right? And we will need event y, basically the vertical position of my mouse, right? And we will also need camera z, which basically how far your camera can see. This is the far clip value, and it's also under camera component. So we have the 2. Let's call this 2. I'm gonna explain that in a minute. So we have the mouse position information for 3D world, right? So once we click somewhere on the world, it will give us the 3D world position like this, right? So we have some sort of 3D position, and we're gonna use that information in a minute. So in order to do a raycast, you need to find the starting point and ending point, because let me explain how raycast works. So for raycast, you have start point and you will need an end point. So once you send the raycast to this position, if there's anything between that raycast, it basically gives that information, like this entity's information, right? So in our case, we have the plane, we have the ground, right? So once you send some sort of raycast from the camera, it will hit there, and we're gonna use that information. So in order to send a raycast, we will need camera position, right? We need to clone it because we don't want to make it so it's just somehow modified by other functions, right? So we have the camera here. This is the from, and somewhere here is just our to vector, which we basically like we got it. We got it with screen to world function, right? Now we need this position, and we're gonna get it with rigid body function, which is under systems. Rigid body, I guess it was like that. Raycast first. Yes, it was like that. Now raycast function has a start and end point, which basically from and to, which is basically from and to. And we have the raycast function right now. So let's just put it in console log so we can see what's going on. So sorry for that. It's not what I want. I guess it didn't update the script for some reason. Yes, sometimes that happens. Just, make some other changes and refresh the page again. Yes, as you can see, it's null right now, right? Because our plane doesn't have the collision. Let's just add a collision to it, right? So we have the collision here like this, and also add some sort of static rigid body, and set some sort of height, so it's like plane. So once you send the raycast to the world, it basically gives us that plane entity in here, and it also gives us some sort of point, and we're going to use that point in a minute. So what I want to do is just see that point in 3D world so I can see if the point is correct or not. So I'm gonna create an attribute so I can see where my mouse hits. So let's just call this test entity, right? So we have this test entity, and now I'm gonna add some sort of spare like this, make it a little bit small, disable shadows, and right now I added that attribute to my camera. I'm gonna parse the script so I can see the chains. Here, as you can see, I have this test entity, right? What I'm going to do is basically set that spare to the test entity so I can use that spare as a test entity, right? So I'm gonna set this test entity's position to the raycast. What was it? Point, right? I'm gonna set it to the raycast point, but I want to make sure that my raycast is not null, right? Because sometimes it's null, it doesn't hit anywhere on synchron like this, right? In that case, I wouldn't have point, and that will basically like crash JavaScript, and I don't want that. So as you can see, if I hit here, it basically doesn't show something because it doesn't get that point. But if I click on plane, it basically set the position of spare to this position, which is amazing. So we have the first part. let's just create a rename script so we can track down what we are doing right now. So we have the rename. Let's just call it. So we need some sort of functionality, point and click, get position. We have this, we got this, we made this. So what we need right now is basically make it so our player can look to this position. So make it so player looks to this position, towards actually, no, and once we do that part, we also need to make it so our player will move to this position, right? So let's just do that part. Let's just create another script called player, right? And let's create an entity called player. Now let's just delete that box. We don't need that box. So we have the player right here. What I want to do is add some sort of capsule in it. So it looks like a player, you know. And what I also want to do is basically add some sort of box so I can make it so it just looks to a direction, right? I'm gonna fix that in a minute, but just let's make it like this, right? So it's like Among Us character, right? Sort of. Anyways, we have the player, and let's attach our player script to it, right? So we have this player script. So what I'm going to do is basically create a global listener for player on application, so our player can move to this position, right? So player move, set move point. Let's just create a function like this. So this will work with a position information, right? So what we're gonna do is basically once player clicks somewhere, we're gonna trigger a function, that function actually, with Raycast point information, right? So we have the position. Let's just debug that part so I can see if everything works properly, right? I have the player script on player, awesome. So let's just click here, for example. Come on. My internet is super slow. Sometimes it just lags and doesn't get the information. So as you can see, we got the information in player script, which is awesome. So what I'm going to do right now is basically just make it so my entity looks to this position. So once I do that, it should look to this position. But as you can see, it just, doesn't look like it doesn't like, it works, but it doesn't work actually. So I'm gonna fix that with a cool way. What I basically create another entity called origin, and what I'm going to do is basically move those things inside this origin, and I'm gonna turn that to this direction. Once I do that, if player turns to a direction, it will turn to that direction, but that doesn't mean my player should be looking to that direction. That once I do that, it will basically add some sort of rotation to the look at function, and that will basically make him look to correct direction. This is kind of cool trick that I use all the time. It works. So as you can see, my player looks to right direction without even refreshing. So once I do that, what I'm going to do is basically just, so I guess we don't need to use position information, but what I can do, actually, let's just, so next position, let's just call this next position, and let's create a vector, right? And let's just set that. So we got the next position each time. What I'm going to do is basically just translate that entity in, it's just, that direction. So it's minus z. So it just moves forward, right? It's like this, but I can make it a little bit slow, I guess. Let me see if that works. As you can see, it just goes to that direction because it basically moves to its forward vector, right? So I have that part. What I'm going to do now is basically make him stop. So I'm going to do it in a weird way. I'm not sure if this is a correct way to do it, but I'm going to basically measure the distance, see if it arrives there. So in order to do that, what I'm going to do is basically get the position of the entity, clone it so it doesn't modify it. It isn't like, it won't be modified by other functions. And I'm going to subtract the next position entity, vector, and measure the length of this. And if distance is just greater than 1, it should move. If it's less than 1, it should stop basically because it won't do anything. So let's see. As you can see, it just, yeah, it stops. Maybe we can just play with numbers a little bit. It's just super not a good way to do it, but I guess it works. And what I'm going to do is basically create an attribute called speed, and set that speed here. So I can basically define the speed to it, to the player. So maybe we can have different speed heroes, right? So let's see. That's awesome. So we have this basically, right? Now what I want to do is basically make it so our camera moves with the player like League of Legends, right? So in order to do that, I want to position my camera properly. Right now, the default position is not what I want, right? So let's just set some values to the 0 and move it to a little bit here and rotate it to the scene like this. Let me see, yes. And rotate it like this a little bit so it's around that, right? So position a little bit like this. It's not like that, I guess. Maybe it's just more from top like this. I don't know. I didn't play League of Legends for a long time. So I guess it should be like this, pretty much, right? So once I have that, what I'm going to do is basically, as you can see, player is at the center. What I can do, like have some sort of base for the camera, right? And move camera inside this base, lock the camera like this. So I'm gonna show you something. So I have this base, right? What I can do is basically just move base with the player. So as you can see, camera position or rotation doesn't change, but the offset changes. So this, you can use this entity tricks everywhere, like origin, base, and stuff like that. So what I'm going to do is basically create a script called chase that will basically follow the camera with the player, right? So let's just create an event called chase position, and this will basically set chase position, right? And we will basically have a next position vector like we did on player, right? And we will have this set chase position, and this position will provide a, so this function will basically provide a position for us. So this next position will basically, so our player will basically send its position to this event all the time, right? So we have this, and we will have current position for this entity because we want to make it smooth, right? And we're gonna set this entity's position all the time to the current position, right? So this the base will have some sort of position that it will chase the player like this, right? And we will use linear interpolation for this. So current position will be set with a linear interpolation. And first parameter is obviously the current position. Second parameter is where we will be going. And the third parameter is time. This is our linear interpolation. So it will basically move this position to here in that amount of time. I'm not sure about this time part, but it will basically make that calculation on each frame, right? So that means we set the next position. Player basically sends its current position to this component all the time, and this component basically sets its current position on each frame, so we have this smooth movement you will see in a minute. And I'm going to attach that script to the chase, sorry, so to the base, so it moves smoothly. Let's see. As you can see right now, it moves like League of Legends or Dota. Maybe we can make it even slower like this with decreasing the number. It will basically move smoothly, right? So we have this. It basically moves where I want smoothly if I click, right? So we can let me think. So let's just take our player will move. We have the smooth camera movement. That's awesome. I guess we can call this part one, and I'm gonna try to add more stuff to this and improve the script. So we have maybe towers, maybe some sort of AIs, and lanes and stuff like that. So let's just call this part one. We can figure out the rest later.